I again welcome you all to my fourth lecture on power generating units, that is working and constructional detail of a hydropower plant. In this lecture we are going to talk in detail about the working mechanism as well as the construction mechanism. How a hydroelectric power plant works. A modern hydropower plant is comprised of a reservoir, a dam, a penstock, turbine and the generators. The reservoir stores the fuel and allows operator to control how much water is to be fed to the turbine. It also serves as a decanter. Most of the dirt and debris in the water settle at its bottom and away from the intake area. Water from the reservoir is delivered to the turbine through the intake and penstock. A filtering system at the intake further cleans up the water to ensure that it is relatively free of suspended solids which could damage the turbine blades. In my PPT that I will share with you, you will find a clear diagram indicating all these structures. Now let us go through hydraulic schemes. The governor, the brakes, the gate controls and so on work together to open and close the apertures that allow water to flow downstream from the reservoir. The water wheel on the past has been evolved into the modern turbine. Differing mainly in their blade shapes and configurations, the three main types of turbine are Francis, Kaplan and Pelton turbine, named after their inventors. All these discussions we have already done in our previous lecture. Regardless of design, the turbine converts the kinetic energy of moving or falling water into mechanical energy. The turbine is connected through the shaft to the rotor of a generator that converts the mechanical energy into electricity. For the greatest efficiency, turbines are custom made for each hydraulic power plant. Each modern hydroelectric power plant relies on multitude of complex systems that monitor, control and improve conditions to ensure operations. Bearing and lubricating system minimizes friction and wear and tear in moving parts. Then filter traps the particulate that can abrade turbine blades. Then we have powerful hydraulic systems open and closes the penstock gates. Then we have cooling system to keep temperature under control to prevent overheatings and fires in transformers, cables, switch gears and other electrical and mechanical mechanism. Hydroelectric plants, also known as hydroelectric power plant, generate electricity by harnessing the energy of flowing or falling water. They have been used for decades to produce clean and renewable energy. The working and construction details of hydropower plants can vary depending on their size and design, but the fundamental principle remains same in all the cases. Here is an overview of the working and construction. So, first one I am going to explain through water source and reservoir. Hydropower plants require a reliable and sufficient water source, usually a river, flowing stream of water or a large reservoir. In some cases, dams are constructed to create artificial reservoir which allow for better control of water flow and energy generation. Now let us see in brief what the function of dam is. In the case of large hydroelectric power plant, a dam is constructed across the water source to create a reservoir. The dam helps in regulating the water flow and maintaining a constant level of water, ensuring a steady supply for electricity generation. Now let us study in brief the intake structure. An intake structure often located near the base of the dam allows water to enter the power plant. It usually includes gates or valves to control the flow of water into the plant. Now in brief I will discuss about penstock because I have already talked about penstock in detail in my previous lecture. The intake structure leads to a large pipe called penstock which carries water from the reservoir to the turbine. Again, the penstock size and design depends upon the amount of water and the head. About head also I am not going to talk here because we have already talked a lot about head in my previous lectures. The penstock size and design depends upon the amount of water and head difference between the reservoir and the turbines. Turbine also we have discussed, so here just I am going to give a little brief introduction. The penstock directs the water onto the turbine. Turbine are large specifically designed machine with blades or buckets mounted on them that convert kinetic energy of the flowing water into mechanical energy. Now come generator. Generator also I have discussed in detail in my previous lecture. So, those who have missed Those who have not seen my previous lecture, please go through and watch my previous lecture so that you will have a complete understanding about all these mechanisms. Generators. Connecting to the turbine, connected to a turbine, a generator is used to convert the mechanical energy into electrical energy. A generator contains a rotating coil or wire with a magnetic field. As the turbine spins the generator, it induces an electric current in the wire, producing electricity. Now we have transmission lines. Once electricity is generated, it is sent through transmission lines to the substations and then distributed to homes, businesses and industries or places wherever it is required. Now in PPT, I will show in detail the diagram of hydroelectric power plant, dam, all the constructional details also. Now let us go through some construction details of a hydroelectric power plant. Number first, site selection. Selecting the appropriate location is crucial. Factors like water availability, topography, environmental impact and local regulations are considered during the site selection process. A well chosen site can maximize energy generation while minimizing environmental and social impacts. Here are some key factors to consider during the site selection process for a hydroelectric power plant. The first factor obviously will be the availability of water source. The availability of a reliable and sufficient water source is a fundamental requirement for a hydro power plant. The site should have a river, stream or other water body with a consistent flow throughout the year. The volume and velocity of water are essential in determining the potential energy generation capacity. Waterhead. The waterhead refers to the vertical distance between the water surface and the intake of the turbine and the point where water is available. A higher waterhead generally leads to increased energy generation. Sites with significant elevation changes or natural waterfalls are favorable for hydroelectric development. Now another factor that needs to be considered is environmental impact, because they assesses the potential environmental impact of the project. They also consider the effects on local ecosystem, fish migration routes and wildlife habitats. It can minimize disruptions to the natural flow of river and consider measures to mitigate any adverse effects on the environment. Then another factor that need to be considered is topography and geology. The topography of the site is crucial in determining the feasibility of dam construction and the design of the penstock. Stable geological conditions are essential for constructing a dam and other structure. Now let us have a look, let us study infrastructure and accessibility. The site should have reasonable access to transport and other necessary infrastructure for construction and maintenance of the power plant. Proximity to existing electrical grids and substations is advantageous for transmitting electricity efficiently. Now comes yet another factor, that is land ownership and legal consideration. Ensure that the site is suitable for development and necessary land rights and permits can be acquired. Understand and comply with the local regulations, environmental laws and community requirement. Then water rights and flow regulation. Determine the availability of water rights for hydropower development. Also assess the possibility of for flow regulation to ensure a steady water supply during different seasons, so that in no seasons there will be a scarcity of water. Then we have social and cultural considerations. Consider the potential social and cultural impact on local communities. Consult with the affected communities, seek their input and address any concerns or grievances. Then we have flood risk and safety. Evaluate flood risk and design the power plant and dam structures to withstand extreme weather events. In the case of rainy seasons also, if the quantity of the volume of water exceeds the required limit, there must be some provisions to improvise without causing much damage to the nearby areas. Safety should be top priority to prevent any catastrophic failures. Then we have yet another factor called as economics and cost benefit analysis. For that we have to conduct a thorough cost benefit analysis to assess the economic viability of the project. Then consider factors such as constructional project cost, potential energy generation, revenue projections and the project's overall financial feasibility. Site selection, as I have just talked few moments ago, is for a hydropower plant requires a multidisciplinary approach that involves engineers, environmental experts, geologists and social scientists. Engaging with local communities and stakeholders is crucial to understand the site's context and addressing potential challenges. Sustainable and responsible site selection ensures the long-term success of the hydroelectric power plant while minimizing its environmental and social impact. Now, in some places we are seeing a dam is constructed for storing the water. Let us go through a brief of this dam construction mechanism. If a dam is required, its construction involves significant civil engineering work because dam is of enormous size. The dam design and material depends on the factors such as water volume, pressure and the geology of the area. Dam construction is a complex and a large scale engineering process aimed at creating a barrier across a river or water body to store water, regulate its flow and generate hydroelectric power. The construction of a dam involves several stages from planning to design to actual construction and commissioning. Here is some overview I have given of the dam construction process. Feasibility site selection. Before commencing dam construction, a feasibility study is conducted to assess the economic, technical and environmental and social viability of the project. Engineers and environmental experts evaluate potential sites based on factors like hydrology, geology, topography, water availability and environmental impact. A site is selected based on most favorable combination of these factors. Then comes engineering design. Once the site is selected, detailed engineering designs are created. This involves determining dam's type, size, height, shapes and material, all these things. The design also considers features like spillways, intake structures, outlets to release water for downstream needs. Then comes permits and clearance. Obtaining the necessary permits and clearance from regulatory authorities is an essential step before construction begins, because you cannot later change anything. This includes environmental impact assessment, land acquisition and compliance with the local law and regulations. Then we have site preparation. The construction site is prepared by clearing vegetation, leveling ground and ensuring stable foundations. Access roads and construction facilities are set up to facilitate the construction process. Then once everything is clear, we go for the foundation construction. The dam foundation is critical to its stability. Depending upon dam type, the geological condition, the foundation may require excavation and in some cases grouting. That is grouting means injection of cement or other material to improve soil stability. Then comes dam construction. There are various types of dams including concrete gravity dams, embankment dams, arch dams and various others also. In concrete gravity dams, formwork is used to pour concrete in layers, allowing each layer to cure before the next layer is poured. This type of dam is constructed from bottom up type. Embankment dams. These dams are built by placing and compacting suitable materials, normally rocks, soils, clay, etc., in layer by layer. The core of the dam may be composed of impermeable membrane to prevent seepage. Then in arch dams or arc dam also it is called. Arch dams are usually constructed in narrow cannons. Here the concrete is placed in a curved shape, creating a strong arch that resists the water pressure. Then we have spillway and outlet construction. Spillways, a very widely used term in hydroelectric power plant. Spillways are constructed to release excess water safely and prevent overtopping of the dam during floods. Outlet works are built to regulate the flow of water through the dam. Then impoundment is there. Once the dam construction is complete, water is allowed to fill in the reservoir gradually. The dam's structural integrity is closely monitored during this phase. Then comes operation and maintenance. After the dam is commissioned, it requires regular maintenance and monitoring to ensure its continuous safe operation. Proper maintenance is essential for the longevity and safety of the dam. Dam construction is a significant undertaking that requires skilled engineering after careful planning, adherence to safety and environmental regulations. Properly designed and constructed dams play a critical role in water management, flood control, irrigation and electric generation through hydroelectric power plant. Once all these structures are done, we come for powerhouse construction, because powerhouse will contain all the turbine and generator units. The powerhouse is the building that houses the turbines and the generators. It is constructed near the dam or within the vicinity to minimize the length of the penstock. Remember, you have to ensure that your penstock is as minimum of length as possible, because creating greater height penstock will only include reducing in head. Powerhouse construction is a crucial phase in the development of hydroelectric power plant. The powerhouse is the building or structure that houses the turbines, the generators and other electrical equipment necessary for electricity generation. It is where the mechanical energy from the flowing or falling water is converted into electrical energy. Now, let us go through the overview of powerhouse construction process. First one will be again here design and planning. The design of the powerhouse is an integral part of the overall hydro plant design. It is based on factors such as number and size of the turbine and generators, the water flow rate, the head, I mean what is the net available effective head at the generating unit of the water, and the capacity, overall power generation capacity of the plant. Engineers and architect work together to create a functional and structurally sound design that meets safety and performance standards. Now, let us have a look at foundation and structural construction. The powerhouse foundation is constructed to provide a stable and level base for the entire structure. Depending on the site of the powerhouse and the site conditions, the foundation may be made of reinforced concrete or other suitable materials. Reinforcement bars and formwork are used during the concrete pouring process to ensure strength and durability. Once the foundation is ready, the turbines and generators are installed inside the powerhouse. These are large and heavy piece of equipment that require careful handling and precise placement. Crane system and other heavy lifting machinery are commonly used during the process. The turbines are positioned in such a way that water from the penstock can flow onto the turbine blades to generate rotational motion. Now, let us talk about penstock connection. The penstock, a large pipe or conduit that carries water from the reservoir of the dam to the turbine, is connected to the intake structure outside the powerhouse. The connection point allows water to flow into the powerhouse and onto the turbine. Now comes cooling system. During electricity generation process, the turbines and generators can generate significant heat. Cooling systems such as water cooling or air cooling are installed to dissipate this heat and prevent equipment from getting overheated. Now comes electrical systems and control rooms. Electrical systems including switch gears, transformers and control panels are installed to manage the electrical output and transmission. The control room is where the operators monitor and control the power plant's various components and processes. Now we have ventilation and safety features. Proper ventilation system are implemented to ensure a safe and healthy working environment for personnel inside the powerhouse. Safety features such as fire safety, then fire suppression system and emergency shutdown mechanisms are integrated to address the potential hazard associated in the powerhouse. Then comes commissioning and testing. Once the construction is complete, the powerhouse undergoes thorough testing to ensure that all the systems are functioning correctly. This includes load testing the turbine and generator to verify their capacity and performance. Now comes operation and maintenance. After commissioning, the powerhouse becomes an essential part of the operational hydroelectric power plant. Regular maintenance and inspection are conducted to ensure the powerhouse reliable performance and longevity. Powerhouse construction requires precise engineering, adherence to safety standards and attention to detail. A well constructed powerhouse is vital for the efficient and safe operation of the hydroelectric power plant, ensuring a reliable supply of clean and renewable energy for many years to come. Now, let us talk about turbine and generator installation. The turbine and generator are massive and require careful installation. Skilled technician and heavy machinery are involved in this process. Turbine and generator installation is a critical phase in the construction of hydroelectric power plant. As these are enormous, they have to be handled with very much of care. These components are the heart of the power generation process, as they convert the kinetic energy of flowing water into mechanical energy and then into electrical energy. So, before going further, let me give you a brief overview of the turbine and generator installation process. First one will be site preparation. Before installing the turbine and the generator, the construction site must be adequately prepared. This involves ensuring a stable foundation for the powerhouse or turbine hall and providing access for heavy equipments needed for installation. Then comes your hoisting and lifting equipments. As I already told you, this turbine and generator units are very heavy, enormously big in size. So, we need a proper lifting and hoisting equipments here. Specialized hoisting and lifting equipment such as cranes and gantries are required to handle the large and heavy components. These machines are essential for safely moving the turbines and generator into the desired position. Now, once everything has ensured, now comes turbine installation. The turbine are installed inside the turbine hall, which is the part of the powerhouse. Depending upon the type of the turbine, like Francis, Pelton, Kaplan, what we are using, the installation process can vary. Now, let us talk about generator installation assembly. Once the turbines are in place, the generators are installed in the same turbine hall or adjacent to it. Generators are heavy and often require a careful positioning and alignment with the turbine shaft. Some minute detail in generator installation we will see now. Let us first see stator installation. The stator is the stationary part of the generator and is installed first. It consists of a core with wire windings which will later generate the electrical output. Now, rotor installation. The rotor is the rotating part of the generator and is mounted on the same shaft as the turbine. It is aligned with the stator to ensure smooth and efficient operation. Now comes your shaft alignment. Precise alignment of the shaft, turbine shaft with the generator shaft is critical for the optimal performance and to prevent damage during operation. Because the turbine shaft is mounted with the generator shaft, the proper alignment has to be ensured. Laser alignment and other advanced techniques are used to achieve this required alignment. Now, let us study in brief the cooling and lubrication system provided in the power generation mechanism. The turbine and generator generate significant heat during the operation. Coolings and lubrication system are installed to ensure proper functioning and prevent overheating. Now, let us talk about electrical connections. The electrical connection between the generator and the electrical system in the powerhouse are made as per the requirement. These connections allow the generated electricity to be transmitted to the grid or other distributing points. Now, testing and commissioning. After installation, the turbines and generator undergo rigorous testing to verify their performance and efficiency. Load testing is performed to ensure that the equipment can handle the expected water flow and electrical load. Next, let us talk in brief about operation and maintenance. Once the testing is successful, the turbines and generators become operational components of the hydroelectric power plant. Regular maintenance and monitoring are essential to ensure their reliable and efficient operation over the plant's lifetime. Turbine and generator installation, as I mentioned earlier, required skilled technician, engineer and specialized equipment to handle the intricate and heavy machinery involved. Proper installation is crucial for the long term success and performance of the hydroelectric power plant. Now, let us talk about transmission line installation. The transmission lines are set up to transfer the electricity from the power plant to the electrical grid or distribution network. Transmission line installation is a critical phase in the development of a hydroelectric power plant or any electricity generation facility. Transmission lines are used to transport the electrical energy generated at the power plant to substations and then to distribute it to the consumers or other part of the electrical grid. Now, let us go through a little bit of overview of the transmission line installation process. First one is route surveyed planning. Before installing transmission lines, a detailed route survey is conducted to identify the most suitable path of the lines, because care is being taken not to pass these lines over much residential areas. Factors such as terrain, land ownership, environmental impact and cost effectiveness are considered during the planning phase. The route should minimize the environmental and social impacts while optimizing the efficiency of energy transmission. Then we have a factor called as right of way acquisition, ROW, sometime also you may find it. To install transmission lines, the necessary right of way must be acquired. This involves obtaining legal permission from the landowners or relevant authorities to build and maintain the transmission lines on their property. Negotiation and agreements with the landowners or stakeholders may be necessary. Now come tower design and foundation construction. Transmission lines are typically supported by towers or poles placed along the route. The design of these towers depend upon factors such as the voltage of the transmission line, terrain, and required clearance for safety. Foundations are constructed to anchor the tower safely. Tower erection. Once the tower foundation are ready, the towers are erected at predetermined intervals along the transmission line. Crane equipment is commonly used to lift and position these towers in required place. Then we have conductor stringing. The conductors, or you can say the wires which are used to carry the electrical current, are strung between the towers. All of you might have seen these towers and electrical lines as we go outside. Conductors can be made up of aluminum, normally we are using aluminum itself, aluminum alloy or steel, and their sizes depends upon the voltage and power capacity of the transmission line. Tensioning equipment is used to maintain the proper tension in the conductors. Then comes insulator installation. Insulators are installed on the towers to support the conductors and prevent electricity from flowing into the tower structure. Insulators are essential for the safe and efficient transmission of electrical energy. Now comes stringing hardware and fittings. Various hardwares and fittings are used to secure the conductors to the insulators and maintain their proper alignment and spacing. Let us see few of them. Grounding. Grounding system are installed to protect the transmission line from lightning strikes and to provide a safe path for fault current to dissipate. Regular maintenance is essential for the proper functioning and longevity of the transmission lines. Inspection, repairs and vegetation management are part of route maintenance activities. Transmission line installation requires a coordinated effort involving engineers, construction teams, environmental experts and local communities. Proper installation and maintenance of transmission lines are critical for the reliable and efficient transmission of electricity from the power plant to consumer or other parts of the electrical grid. Now let us talk a few factors related to environmental considerations. Hydropower projects often have environmental impacts including changes to river ecosystem and wildlife habitats. Environmental impact assessment are conducted to mitigate adverse effects. Environmental considerations are of utmost importance in the development and operation of hydroelectric power plant or any other energy projects. These considerations involve assessing and mitigating the potential impacts on the natural environment to ensure that the project is sustainable and minimizes its adverse effects on the ecosystems and biodiversity. Here are some key environmental considerations for hydroelectric power plant. Number first, ecosystem impact assessment. Before starting the project, an extensive environmental impact assessment, that is also sometimes refers to as EIA, is conducted to identify and evaluate the potential effects of the power plant on the surrounding ecosystem, wildlife habitats and biodiversity. The assessment should consider both the short term and long term impacts. Then we have water flow and fish or aquatic life migration. Hydropower projects can disrupt the natural flow of rivers, affecting fish migration patterns and spawning. Designing fish ladders or other fish passage system can help maintain fish populations and promote ecological balance. Then water quality and temperature. The alteration of water flow and reservoir formation can lead to changes in water quality, and temperature monitoring and managing water quality are crucial to safeguard aquatic life and maintain social or ecological integrity. Then we have sediment transport. Dams can trap sediment and nutrients, altering downstream habitats. Sediment management strategies should be implemented to mitigate this effect. Then we have riparian and wetland preservation. Maintaining riparian zones and wetland around the reservoirs and river banks is essential for preserving biodiversity, filtering pollutants and preserving erosion. After going through all these details of the constructional mechanism of this hydro plant, now let us have a look at training and safety protocols. All the personnel involved in the constructional and operations of power plant receive thorough training on safety protocols, emergency procedures and hazardous awareness. Regular safety drills and refresher training sessions are conducted to reinforce safe practices. Personal protective equipments PPE. Workers are required to wear appropriate personal protective equipment such as hard hats, safety goggles, gloves and high visibility clothing to protect against potential hazards of the at the construction site or within the power plant. Then we have lockout, tagout, LOTO. LOTO procedures are followed during maintenance and repair activities. This involves locking and tagging electrical switches and equipment to prevent unexpected energization and protect workers from electrical hazard. Fall protection. Given the elevation of the work area involved, fall protection measures such as guardrails, safety harnesses and safety nets are implemented to prevent falls and protect workers working at heights. Then electrical safety. Strict adherence to electrical safety protocols is essential. This includes proper grounding, insulation and regulation inspection of electrical equipments to prevent electrical shocks. Then we have fire safety measures. Fire suppression systems, fire extinguishers and fire resistant material are installed to minimize the risk of fires and ensure quick response in case of emergency. Then water safety is also involved here. Safety measures are put in place to protect workers from potential hazards related to water flow, water pressure and changing water level in reservoir or spillways. Emergency preparedness. Comprehensive emergency plans are developed to address potential incidents such as floods, equipment failures and dam breaches. Evacuation routes and assembly points are established and personnel are trained to respond effectively during emergencies. Then we have environmental and wildlife safety. Safety measures are also designed to protect the environment and wildlife. Fish protection system and safe fish passage structures are employed to prevent harm to aquatic species during operations. Now, public safety. Hydropower facilities are often located in or near populated area. Safety measures are taken to protect the public from any potential hazards related to dam operation, water release and other facility activities. Regular inspection and maintenance is also carried out to identify and address the potential safety issues promptly. This include assessing the integrity of the dam structures, the penstocks, turbines and critical components. Then compliance with regulation and standards established by the government. Established power plants must comply with safety regulations and standards set by the relevant authorities. Regular audits and assessment ensure that safety measures are up to the mark and date. Safety measures are continuously reviewed and improved based on experience, best practices and advances in technology. A strong safety culture, active communication and commitment from all personnel involved are vital to maintaining a safe working environment in hydroelectric power plant. Overall, hydroelectric power plant are significant engineering projects that require careful planning, construction and ongoing maintenance to ensure efficient and safe electricity generation. So, this was all about my lecture number 4, which include the construction and working mechanism of hydroelectric power plant. In this lecture, I hope you all have got all the basic information about the components involved in hydroelectric power plant, their construction, their working, as well as in the last part of my discussion I have talked about the safety measures that is followed, that is practiced in any hydropower plant. So, this was it about my lecture 4. We will again meet in my lecture number 5. Hope you will find this lecture informative. Thank you all for listening.